So we have the following problem. It says, as part of a biology experiment, a scientist needs to add 2.52 grams of glucose to a reaction mixture. And it asks, what volume in milliliters of a 1.23 molar glucose solution should she use? So here we have a classical concentration mole relationship type of problem, where we know we have to use moles, we know we have to use molar mass, we know we have to use some type of volume. What we just need to determine in which order am I going to solve this. So we may have an idea in our head as as soon as we read the problem, because we see mass, okay, maybe I have to change it to moles, and I see molar concentration, okay, now I know that I could do some type of relationship with volume, but we need to map it out first. And in order to do that, we need to first see what type of information we're given, right? And we are given first up the mass of glucose that she needs to add. So she has 2.52 grams of glucose, or we could write it in the formula form, which I rather do. And we also have the concentration of glucose solution she is using. So you write that as well. Now we need to find the volume. So she's doing an experiment. She needs to add 2.52 grams of glucose, but she has access not to the solid substance, but a solution. So she needs to add that amount of mass using this solution. So first, we need to see what information that is given to us we can use first. Well, if we take this mass, or actually not even the mass, we can take the formula and we can actually calculate the molar mass. So in order to do that, we need to multiply the mass of carbon and multiply that by 6. Then we have 12 times the mass of hydrogen and 6 times the mass of oxygen, and that would give us 180.2 grams of glucose per mole of glucose. So if you don't know how to solve this yet, then I suggest you do take a moment and figure out how to calculate molar mass, because this is super important in this type of problem, especially when we're doing a relationship between moles and mass and volume when they give us a concentration of a solution. So we just calculated the molar mass, and I'm going to erase this so we have a little bit more space for the actual problem. We have 180.2 grams of glucose per mole. Of glucose. So we actually have pretty much all the information we do need. So we can actually go from the mass they give us to the moles we need, and then establish a relationship between that and the concentration that is given. So let's do that first. We'll do it in another colors just so it's obvious. So let's do that in blue. We have 2.52 grams of glucose. And we actually need to change that into moles. So we'll put 180.2 grams of glucose over here. So we can cancel that out per mole of glucose. So that helps canceling those units out. But now I have moles of glucose, which is not my goal. My goal here is to know how much volume does she need. And luckily, obviously we have our solution, our concentration. So what does the concentration actually mean? Well, it means that she has 1.23 moles of glucose per liter of solution. So we need to know how much solution does she need. And regarding to what I just said, we can actually use that as a conversion factor to change from moles to the amount of the volume that we need. So we'll open another set of parentheses so we can put that here. So we have 1.23 moles of glucose, and that is per 1 liter of solution, abbreviated that way. However, we don't, well, actually we do want volume, but we just don't want it in liters. So even though we do have our goal, kind of having the volume, we don't have it in the units that it requires. So we need to add one more set of parentheses and do that conversion where we have per liter of solution, we have 1,000 milliliters, or 10 to the power of 3 milliliters of solution. And now we have the desired units at the end. And for this specific type of problem, I don't use mental math at all. I use my calculator. So I would insert the values, so that means 2.52 divided by 180.2 divided by 1.23 times 10 to the power of 3 would give us 11.36948.105 milliliters of solution. But we need to check with our significant figures. And given that we are given 3 significant figures in this problem, we need to round it up. So we do need 11.4 milliliters of solution. And that would be our answer.